Okay, so here we're looking at indirect proportion. So things are said to be indirectly proportional if when one of them increases, the other decreases. So we've already looked at direct proportion, which is where they both increase at the same rate. Well, this one is when one of them goes up, it causes the other one to go down. So a lot of the examples that come up in these instances are involving time. And so something we can consider comparing would be speed with time. So the faster you drive your car, the quicker you're going to get somewhere. Okay, the less time it takes. So as your speed has gone up, the time it takes has gone down. Okay, so that's the kind of idea that we're looking at behind indirect proportion. But it follows a similar setup. Okay, but there's just one slight difference that's going to change the way in which we work out our answers. So we're still going to set it up by comparing what it is we've got. So it takes 3 people 8 hours to paint a room. How long will it take 4 people? So I'm looking for how long will it take. So I want the time to be on my right hand side, so the number of people comes on the left. So it takes 3 people 8 hours. Okay, so here I've got people to time. If I want to find how long it would take one person, I'm going to have to do something slightly different now. It is going to take them 3 times longer to do it than it would do if there were 3 people doing it. Okay, so you imagine actually having to paint a room. If you get some of your friends to help you, you're going to get it done quicker. If it's just you, it's going to take longer. And so in fact, to find out how long that is, this time we're going to multiply. And I want to know then how long it would take 4 people. It's going to take a quarter of the time. Okay, so if you imagine painting a room, rather than you having to paint all the way around it, you can all take a wall each and you can get done a lot quicker. Okay, so this one here, this comes to be 24. So what we're going to do is now we're going to divide it. 24 divided by 4 is 6. My units were hours. So it's going to take 6 hours to do it. So if we think back to the question, does our answer make sense in terms of the context? Because it's a different setup this time. So what we said is it takes 3 people 8 hours to paint the room. If there are more people, should it take longer or less time? Well, it should take less time if there are more people, and 6 hours is less than the 8 hours that they started with. Okay, so the answer makes a bit of sense, even though it's a little bit different to how we did it before. And so you'll not get told in the questions whether they are direct or indirect proportion. You need to be able to decide which way round they go. Okay, moving on to another example. If it takes 5 people 12 hours to clean a fleet of trucks, how long is it going to take 4 people? So again, setup we've got people to how long. Okay, how long will it take? That was the question we wanted to know the answer to. That's the thing that needs to go on the right hand side. People, the other thing, goes on the left. So if it takes 5 of them 12 hours, it's going to take one person 5 times longer. Okay, so we get 12 times 5. As we're working through it, just like the last one, we don't need to crunch out the answers to this as we're going. We can keep it in our working. Instead though, if we've got 4 people doing it, it is going to take a quarter of that time. And so 12 divided by 4 would be 3 times 5 is going to give us 15 hours. And again, we want to have a look and see. It took 5 people 12 hours to do it. If you've got fewer people helping clean the trucks, is it going to take them longer or less time? It's going to take them longer. Okay, and so this instance, 15 hours is longer than 12 hours, so that meets the kind of conditions that we were thinking about. So one of the things you need to be able to do is you need to be able to separate what happens with the things, right? Do they both increase, or does one increase and one decrease?